Okay guys, in this section 9-6 we're going to be looking at equations of conics. Now we have already had a section on each one of these specific conic sections, right? And so what we're going to do in this section is kind of tie everything together, all four different types of conic sections. And the kind of question that you're going to be asked here this time for this particular section is one where you're going to be given characteristics, okay, about the conic section, and you're going to have to write the equation in standard form. Okay, so kind of what we've done in the past is we've been given the equation in general form, we turned it into standard form, and based on that equation we wrote down different characteristics, okay, like the focus, the vertex, and all those kind of things. This time we'll be given those characteristics, and we have to use those characteristics to generate the equation. And like I say, we're tying every type of conic section together. So since that's the case, what you'll need is you'll need to have your notes for circles, ellipses, parabolas, and hyperbolas handy so that you can refer back to those standard forms of those equations as we go through and need them in whatever particular problem we're looking at. Because like I said, this section we'll be practicing all the different types of conics, all right, that we've looked at. Okay, so the first one we have is one where it says write the equation of the circle, and it gives us these characteristics. The center is at -3, -1, and the diameter of the circle is 2 square roots of 7. Well, remember, for a circle, what do we need to know? Well, we need the center and the radius. They've given me the center and the diameter, which I can turn to the radius by just dividing it by 2, so my radius will be square root of 7. Now I'm ready to write the equation. So it's going to be h, remember change the sign, plus 3 close squared plus y, and minus 1 will change to plus 1 close squared. Anytime you're dropping that circle in the equation, make sure that you change the sign. And then square root of 7 squared is 7, and then there's your equation. So circles, not too difficult, because all you need is the center and the radius, and that typically, the majority of the time, they'll give you plenty of information to be able to come up with those values. All right. And so now let's change gears and go to an ellipse. So here's what we have on the next one. It says write the equation for an ellipse with vertices at -4, 4 and 6, 4, and a focus or foci at -2, 4 and 4, 4. Now, when you're dealing with an ellipse or a parabola or a hyperbola, the first thing that you need to determine is whether the orientation is vertical or horizontal, because that will make a difference on the form of the equation, right? So like for ellipsis, whether it's horizontal or vertical makes a difference whether the A comes first or the B comes first, you see? So we have to make sure that we make that determination so that we can get the equation correct. So how do we figure that out? Well, they've given me all the vertices, so all I need to do is look at which coordinate is the same every time, right? So if the vertex is 4, the y coordinate is 4, the y coordinate is 4. For the foci, y coordinate 4, y coordinate 4, because remember, these will line up either vertically or horizontally. And if they line up along the y-axis, the y coordinate 4, 4, 4, 4, 4, then it's going to be horizontal, because if it lines up at the same height every time, then it's going to be oriented horizontally. We can verify that by looking at this. Okay, so take a look at this. The foci is K. The vertices are K, right? So these two match up with the same K. There's nothing added or subtracted to it. So the K would be the same for both of these. And so since the K is the same for the vertices and the foci, then we understand that the orientation for this ellipse is horizontal. Okay, horizontal. Okay, so now that we know that, we can determine that this is the form of the equation that we're going to target. So what do we need? We need the center, H and K. All right, so we'll have to make sure that we come up with that. And then we'll need to get the values of A and B. So those are the three things that we need, center, A, and B. Okay, so the center, how can we obtain the center? Well, remember, the center is going to be the midpoint of the two vertices or the midpoint of the two foci, either one, right? So if I wanted the center, I just need the midpoint of these two, right? So from 4 to 6, right? So I can add them together and divide by 2. 6 minus 4 is 2, divided by 2 is 1. So my center is 1, comma, the midpoint of 4 and 4 is 4. And if we wanted to verify that, we could, right? What's the middle of negative 2 to 4? 4 minus 2 is 2, divided by 2 is 1. So you can take either the midpoint of these two vertices or the midpoint of these two foci in order to come up with the center. All right, so now, okay, the next thing that I need to figure out is how to get the values of A and B. Okay, now let's come back here to this. Okay, remember the value of A when we're looking at this. Okay, don't forget the value of A when we're looking at this is going to be from the center to the vertex. From the center to the vertex is the value of A, right? If you remember back from when we did 9-2. Okay, so from the center to the vertex, that's the value of A. Well, how far is it from the center to the vertex? Well, it's 1 to negative 4 this way, so that would be 5. And from 1 to 6 this way, that would also be 5. So it's the same either way. So my value of A is 5. Remember, that's from the center to the vertex. In an ellipse is the value for A. Okay, now we also need B in order to write out our equation. All right, and the length of B is going to be from the center to a co-vertex, right? However, we don't have any of the co-vertices listed, right? And we can either go through a lot of work to figure out what it is, okay? Or the alternate method is we can just get C and then use the equation to solve it for B. That would probably be a little bit shorter. All right, so let's see if we can come up with the value for C. So what is C? Well, C is from center to the focus. C is from center to the focus. Center to focus. So center, 1, to the focus, negative 2, so that would be 3. And from 1 to 4 is also 3. So the center to the focus is 3. So that's center to the focus. All right, center to the focus is 3. Okay. Now, I can use A and C to get B, right, from this equation right here. C squared equals A squared minus B squared. So C squared equals A squared minus B squared. Then I'll have C is 3, so that's 3 squared equals 5 squared minus B squared. Okay. And so let's see, we can do 25 minus what? 9 is 16. And then the square root of 16 is 4. So my B would be 4. So now I've got everything to go in and write the equation for the ellipse. Okay, I have my center, and I have my A, and I have my B. Remember, we already determined that it was horizontal, so I'm going to use this form. And when I go to write it in, it'll look like this. It'll be H, and then minus 1. Minus 1, close, squared, over, now remember it's going to be over A squared, and A we already found as 5, so that'd be 25 when I square it, okay, plus, open, Y, back to the vertex, plus 4 changes to minus 4, over, B, which we found to be 4, which will square out to 16, and then that's all equal to 1, and then that is the equation of this ellipse. Okay. So once again, first thing we did was determine the orientation, vertical or horizontal, by looking at the points it gives us. Then using these points, we came up with the center. Okay, we came up with the A and the C. Use this equation to solve for the B. Then we had center A and B to plug into the correct equation. All right. So like I say, it is important from the very beginning to get the orientation down so you'll know which one of the two forms you're going to be using. All right. Next, we have to write the equation for a parabola with a focus at 3, -4 and a vertex at 1, -4. All right, so I'm going to go and find my notes on parabola. And so since this is the notes that we're looking at right here, and once again, just like for an ellipse, a parabola has two forms. One form for a vertical parabola and one for a horizontal. So again, it's very important to see which one that we have here. Okay, so which one of our coordinates are the same? Okay, so my y coordinates are the same for both of these. So if the y coordinates are the same, the focus and the vertex should line up horizontally. They'll line up horizontally. So this is a horizontal parabola. And again, you can double check and verify that by looking at these characteristics. So the y coordinate is the one that stayed the same. So vertex K and K for the focus stays the same. It doesn't change. So if the y coordinate of the vertex and the focus are the same, it opens horizontally. That's what we've got here. So now we know which one of the two forms that we're going for. We're going for the horizontal one, which would be the second one. So that's the setup that we'll use. Now, what are the things that we need for the equation of a parabola? We need the center, right? Got to make sure that we have the center, okay? And we need the vertex. We need the center and we need the vertex. Or excuse me, not the center. The HK is the vertex, I should say. So we need the vertex, right? And we need the value of P. So I misspoke earlier. So HK is the vertex, and then we need the value of P. Well, the vertex we have. They've given us that. All right. So the only other thing I need to write the answer is the value of P. Well, how can we find that? Okay, so remember, the value of P is going to be the distance between the focus and the vertex. Okay, so the distance between the vertex and the focus, right, is going to be the P. So from vertex to focus, that's your P, right? And so what we can do is we can just see how far it is from the focus to the vertex. And so from 3 to 1, that's 2, so the value of P is equal to 2. And once again, what is that distance? It's vertex to focus. Vertex to focus. Okay? So now we have the two things that we need to write our equation for the parabola. Again, it's horizontal, so I know I'm going to be using this second one right here, which as we go to fill it in, it's going to be y. And -4 will change to +4. Remember, the K goes with the y. Close it off, square it. We're going to set that equal now. Well, if my P is 2, then remember here we have 4 times P, so 4 times 2 is going to turn that into 8. And we've got x plus 1 changes to -1. We close it off. We square it. That is the equation of the parabola. All right, so like I said, unless it's a circle, it's very important that we decide whether our conic is oriented horizontally or vertically, because they all have two forms except for circle. Okay? All right, what about the next one, though? See if we can write a hyperbola, the equation of a hyperbola with vertices at -3, -6, -3, 2, and foci at -3, -7, -3, 3. Okay? So once again, as I go through and find my notes for a hyperbola, we do, again, have two forms, right? We got two forms for the equation, depending on whether it's horizontal or vertical. So we need to determine that first so we know which one that we're going to have. And so as we take a look at this, it looks like my x coordinates are all the same. So if you're left 3 every time for the points, or all left 3, they're going to line up vertically. All right, so that's going to be a vertical oriented hyperbola. And once again, if you wanted to verify that from the chart, all the h coordinates are the same, right? And so if all the h coordinates are the same for the vertices and the foci, then you know you have a vertical hyperbola. All right, and that's what we have. So what do we need in order to write the equation of a hyperbola? All right, so as we're looking at the equation, we know we're going to need the center, right? Okay, so h and k is the center. So we'll need to figure that out. We also need the a and the b. So we'll need the center, we'll need the a, we'll need the b. We'll need the center, the a, and the b. Start with the center. Okay. All right, so my center is going to be the midpoint of the vertices or the midpoint of the foci, kind of like what it was with an ellipse. So first of all, we know it's -3. So the middle of -3 is -3. The middle between -6 and 2, add them together. -4 divided by 2 is -2. So -2 is halfway between -6 and 2. Verify it again here. -3 or -7 plus 3 is -4 divided by 2 is -2. So we do have the right center. Now we need the values of a and b. Well, what is a? Let's see what a is. Okay, so the value for a, remember, is from the center to the vertex. A is from the center to the vertex, right? So if I count from the center to the vertex, I can get the value of a. So from the center to the vertex, from -2 to -6 is a value of 4. It's a difference of 4. And from -2 to -2 to +2, either way you go with the vertices, it's still 4, right? And so that would be 4 either way. And remember, the a is from center to vertex. All right, center to vertex. Now, we also need b, okay? But remember, your b is going to be from the center up to this point, okay, which is something that's difficult to determine with the points that we have. However, we can't get the b, but we can get the c, because remember, in a hyperbola, the value of c is from the center over to the focus. And so we can get the c because we have the focus. So from center to focus, that's going to be from -2 to -7, and so that's a change of 5. And if you check the other focus, -2 to +3 is also 5. So it matches up. And remember, that's center to focus. All right, center to focus. And so remember, c is not a value that we need in order to write the equation, but c is going to help us find b, which we do need for the equation. All right? And so we'll have this equation, c squared equals to a squared plus b squared this time. So that's how the three values are related. Right? So we get that equation from here. That's how they're related. And so when I go to plug in, we'll have 5 squared equals to 4 squared plus b squared. All right? And so, of course, when we solve that, we get b is equal to 3. And then so now we've got everything to go in and write the equation for the hyperbola. And so remember, we're vertically oriented. So we'll start with this. The y's will come first. So this is going to be y. And using my center, and remember the k goes with the y, so that's +2. Close it and squared. All right. Over. And remember now, this is going to be my a, right? This is going to be my a. And so my a is coming first. 4 squared is 16. Minus. Got my x term here now. It's going to be +3. Minus 3 changes to +3 from there. And that's going to be over your b squared. So my b we found to be 3. Squared is 9. And of course, must be equal to 1. All right. So again, that's how we'll use the characteristics given in order to come up with the equation of the conic section that they have asked for. Now we are done, folks, with Unit 8.